Hi everyone, can you hear me? Can everyone hear me?
Yeah, yes, Anuj.
Okay.
Others, please
Okay.
confirm.
Hmm? Okay, so you should be hearing me now. Okay, so everyone is hearing, right? Okay, let's start. Just okay. My name is Ahmed Salah. I am Ahmed Salah. I am a competitive programmer, and I have quite a lot of experience in competitive programming, like 3 years. Uh, That's it. Participated in many contests: Code Forces, Code Chef, AdCoder, Top Coder, all of the many, all of the top platforms for competitive programming. So let's start. Right. Let's start with a problem. I'll post it to you here in the chat. So please, everyone, read this problem. Make sure you understand it to solve it. Okay. Just I'll give you 2 to 3 minutes to read it carefully and understand what does it say. Okay, did everyone read the problem? Hmm. Can you hear me all or not? Uh, just confirm if everyone read the problem. Okay. Okay, good. Does anyone have any idea how to solve this problem? Just give ideas, something like that. So no ideas from anyone? No one wants to speak? Uh, okay. Okay, let's start right at. Okay, since I want this to be interactive, so I want you to speak with me. Like, say to me if you don't understand anything, something like this. Also suggest ideas. Okay. Uh,
Ahmed, could you please show the question in your screen and check with the people if they understood the problem properly? Uh,
okay, I'm asking, but no one is speaking. Okay, so can you all see my screen, Visual Studio Code? Uh, so do you see my screen, Visual Studio Code? Okay.
Yes, Igor.
yes, yes.
Okay. Um, so did everyone understood the problem correct?
Yes.
Okay. Any ideas or no ideas from anyone? Any ideas how to solve this problem or no? Okay. So you seem to understand it. Okay. Okay. So I'll say the problem here. Um, we are given a matrix of size n times m. Okay. So nm of size n times m. So n rows and m columns. For each cell, this matrix it it is either a wall, so it's represented by this hash, or a dot, which is empty cell, or it is good, so represented by G, or it is bad. Okay, so it is either hash, dot, good, bad. So our goal is that every good person should should end should can walk to the cell at the place n minus one, n minus one. So if the matrix is like this, so our goal would be to make every good can reach this last cell, the cell in the in the right downmost corner. Okay. For every person, he can move to any adjacent cell. So this person can move to the this upper cell, or to the cell to the right here, or down here, or to the left. Okay. So any person can move to any adjacent cell of the four adjacent cells, either right, left, up, or down. Also, there are bad persons. And also there could be some walls here in this matrix. So at any time, a person cannot move to a whole cell. So it can only move to any adjacent cell that is empty, means that it's dot, or it can move to any adjacent cell that contains another person. But we want to make all good persons reach to the end cell here, but without allowing any bad person to reach this cell. Okay, so something like if we have only this bad person, um, and these two goods, this bad could reach to the end. So this matrix is not good. So we want to modify it to make only good persons reach the cell. How could we modify it? The problem says that we could put any wall to any cell. Of course, it should be empty. Okay, so we could put wall here, here, or anything. Okay, so for this particular matrix, we could put walls around this bad person. If we are to modify this matrix, we would put three walls here. So now we are sure that this bad cell cannot move. This bad person cannot move. So all the good persons will reach here to the end. Okay. Also, we need to make sure that no good person is stuck and cannot move. So if a good person cannot reach this end, so it will be wrong. So if we have a wall here, so obviously this is not possible for the problem. This will be wrong because this good will not reach. So we want to make sure that all the good persons reach to the end and no bad cell reach to the end. Okay. So let's see how could we solve this. Anyone have any idea how to solve this? It would be good if you share any idea. Okay. Okay, backtracking. Not quite. Uh, how backtracking should work here? So we will try every cell. If you can talk, it will be better. DFS. Okay, but before using DFS, if we are to use DFS, how should we modify the matrix to make all the good people pass and no one from the bad people pass? We want to modify it first. How could we do that? Mm, okay, let's see. Okay, so to see how could we modify the matrix to block all the bad people. So our goal is to block all the bad people without blocking any good person. Okay, so now let's pretend we have a matrix that contain. We will consider only bad people. Okay, so we'll be having good peoples in some other cells, but we want to consider them now. What's this red? Okay. Um, we now have we consider that we have two bad people here. We want to block them that to make them not reach the end cell. It turns out that the most optimal way is to check for all of its adjacent cells and block them. Okay, but why is this true? We said that we want to make sure that any good person would be able to reach, right? So why are we sure that blocking all the four adjacent cells will be enough without distracting any good people from passing? That's why that's because if if we didn't block this cell to not block any good people, any good if we didn't block this cell and the bad person could pass through this cell, it's always we always need to make sure that this bad person uh, isn't passing. But what if we have something like this. So our initial matrix is something like this. Okay. Um, we don't consider these. We will also check for the 4 adjacent cells. Okay. So you may now see that it won't be, it won't matter if we block this or not. It won't matter. But actually, we don't know that this matrix is blocked in somewhere else. So we will also block this point. And if there is any good within this square, then for sure it will not pass. So it won't make any difference if we blocked an additional cell. So we don't need to block this cell, right? But we will block it because we are not sure that we have another cell that's blocking this bed. Okay, so we will try. So the optimal way to be sure that no bad any bad person passes, that we will block all the 4 adjacent cells first. Okay, either it contains wall or not, we will block it. Okay, so that's it. After this, we should have like some good people here. After blocking all the adjacent cells, we want to make sure that all the good people are able to pass, and here we are able to pass until they reach the end cell. And here where DFS comes. So it's clear that from this matrix, it's not possible. Okay, but let's make simple thing here. Okay, so for this matrix, it's clear that this good will walk through this path and then go here. Okay, and this good also will walk through this path and then go here. Okay, so what we'll do is we will run DFS from here and then check if it visited all the good people and it didn't visit any bad one, then we'll be okay. So this matrix will be good. We'll print yes. Otherwise, we'll print no. Okay. So just run DFS from here and check if we reached all the good people. Okay. Okay. I'll check for the statement if I can place a block in a good and a bad person or not. Okay. Let's start with the input right away. So first I should take an integer t, which represents the number of test cases. So here I'm writing C++, okay? I'll take an integer t, which represents test cases. And then, what should I take? And then I should take n and m. So we want to initialize a matrix here, but we will not initialize it in this inner loop, because every time every test case the matrix is changed. So we'll initialize a matrix here with a full size at global. Okay. So we'll make it's actually character. So the maximum size for n and m is 50 actually, right? Yes. Maximum size for n and m is 50. So we'll initialize it there. Also, yes, we'll take the matrix. So now we took the matrix from the input. One thing here is that we also need to take n and to initialize n and m at global, because when we are doing DFS, we want to make sure that we check the bounds. So we will make everything global. Okay. Also, for the sake of DFS, we'll make a visited Boolean array. We'll use it later. Okay. Okay. So here, after we took the input, we want to make this modify just to block all bad people. So what we'll do is so simple. We will loop through every cell. So we will loop and check for every bad person. We will try to block all the other 4 cells. Okay. So for int I equals to 0, so here we check if this is a bad person. So if mat of I of j equals bad, so we'll block all 4 cells, right? So instead of just looking every cell in its own, so we'll make a function. That will block any cell for any I and j, just to make code look simpler. Okay, so just make a function of void called block. It takes int I and j. So these are the indices of the cell, and we want to block it. But first, we want to check if I and j are in the bounds of the matrix. So because if I'm here at like 0 and 0, so if I am at cell 0 0, and then I called the left matrix and the upper matrix, of course this will be an out of bounds, right? So I want to check if I am at any cell, I want to check if this is valid or not. So also again, I'll make a Boolean function called check. Also it will take int I and j. For this function, I'll return the right positions for I and j. So if it's not between n and m and 0 and 0, so I return false. So I'll just return one condition here: I greater than or equals 0, j greater than or equals 0, I small that's 0. Okay. So for this check, it will return false if the cell ij is not in the bounds of nm and 0 0. If it's in the bounds, it will return true. Okay. So here I'll say if check ij, if ij is in the matrix, and if it's empty, actually, because if it's not empty, then I won't do anything. If it contains any person, like good or bad, I cannot block it, because it doesn't say this in the statement. But if I have any person here, like G, and I want to block this cell, I cannot, because there is a person that will pass here. Okay, so there is a person that will pass here. So here, if mat ij equals dot, so if it's in the bounds and if it's empty, then I'll just put a wall in it. So mat ij equals 4. So that's it. So this function will block any cell I want. Let's back here. So I want to block all the 4 adjacent cells. I'll just call block 4 times. So block I plus 1 j, the lower cell. Then block I minus 1 j, the upper cell. Block I j plus 1, the right cell. Then block I j minus 1. This is the left cell. Okay, so now I tried to block all the 4 adjacent cells, and then what's only left is to run a DFS. Okay, so here we'll make a DFS. DFS it will be, so before writing the DFS, I will run this DFS from n-1, n-1. So this is the last cell. Okay, as I said, I'll run DFS. Actually, you can do also BFS. Okay, so we can do BFS from this last cell or DFS, but DFS is much simpler. Okay. First, we want to initial. Do anyone want to speak? I heard the voice. Okay. First, I want to initialize this visited array with zeros. Okay. Okay, so before entering any test case, I will initialize this visited array to 0. Okay, so if so this is how DFS runs. So if I am in a non-visited array, then I continue the DF. In a non-visited cell, then I continue the DFS. So I'll check if this cell is not visited. If not v of I of j, then continue. Okay. Also, I want to check if it's not visited and it's within the bounds, right? So here where it comes this check function handy. Okay. Then I check ij. So if it's not visited and if it's within the bounds, then I'll continue the DFS. So I'll make it first visited. So v of I of j equals 1. And then simply I'll run DFS for the 4 adjacent cells. But first, we want for every cell we visit, we want to check if it's good or bad or just anything else. Because if it's bad, then there is some bad person that I've visited, and here and this will return false. And if it's good, I will count the number of good people I visited through the DFS to know if they are all the good people or not. Okay, so let's make a global variable again here, call G and B for good and bad. Okay, let's make this good, bad. Okay, and let's for each test case let's initialize a variable called B. B refers, so let's make it initial. Let's make it okay. Initial good. So initialize a variable called initial good. So these are the initial good people in the matrix, and then we'll count them, of course. And then after we run the DFS, we will count the good people we have reached. And if these are equal, if initial good equals to good that we counted from DFS, then we're okay. All good people we've reached. And if the bad people we've reached from DFS is greater than 0, then we're not okay. Okay, so just simply while taking every element from the matrix. If this element is good, then I'll increase initial good. Okay, so I'll make initial good plus equal mat j equal g. Okay, so if this element is good, I'll plus initial good to 1. Okay, but with initializing this visited array to 0, I want to initialize g equal b equals to 0. Okay, these are the global value. Actually, good, bad. Initialize good equal bad equals to 0. Okay, so here I'll make good plus equal mat j equals g. So if it's good, I'll plus good, and bad plus equals mat ij equals b. Okay, and then simply DFS through the 4 adjacent cells. Okay, so I call DFS again. So DFS I plus 1j, DFS I minus 1j, DFS I plus 1, DFS I j. Okay, so that's it. That's our DFS. So at the end, after DFSing from the last cell, I want to check if initial good equals to good and not bad, or bad equals to 0. So if the good people at the initial at the start are equal to the good people I reached from DFS, okay, then, and if the bad people I reached from the DFS equals to 0, then of course I'm okay, right? Then I'll say out yes. Yes. Then I'll say out yes. Else I'll say out no, right? Okay. So that's it. Let's check the code. So if anyone have any question in this simple might be simple code, ask me. Okay. If there is some point you cannot get it, I'll make this greater here. Okay, let's check the samples. Yes. Seems like there is a bug. Yes. Here in the DFS, I want to check if it's empty. I forgot this. So after checking if it's not visited, and after checking if it's in the bounds, I want to check if this cell is actually empty, right? If not ij equals to dot, then I'm okay here. Okay. There's something here. Let me check the statement if I can place any cell with wall. Check. Okay, actually I didn't save the code, so it runs here correct. Okay. Okay, so here is the final code. Of course, I'll submit it, code forces, but I want to know first, is there any is there any point that it's not clear in this code? Do you understand everything? If anyone has a question, just tell me. Okay. Okay. Let's try to submit it. Okay, you should be seeing my whole desktop now. Just need this. It should be okay. Okay, accept it. So if you want the code, I'll send it to you in the chat here. Okay, here's the code for this problem. Make sure to keep it understandable. Okay. Okay, let's go for another problem. I'll get it to you. Okay, here's the problem. Just fetching it. I'm just looking for an easy problem to fit in, to be solved easily. I'm getting it now. Okay, here's an easy problem, ad hoc. It doesn't require any algorithms. Okay, I sent it. Actually, do you all see the sent? Okay, I'll send it again because it seems that it's not sent. Okay, so here I sent two links. The first one is the submission for the last problem. The last one is the new problem. We'll be solving it now. Okay, so read it and make sure to understand it.
Ahmed, sorry to interrupt you. Actually, we have one more meeting at after 20 minutes, and we'll be using same account. So uh, can we finish it off in 15 to 20 minutes? Else, let people go through these problems, and maybe next session when we have in Monday morning, um, they already be coming with after reading this problem, after understanding this problem, and then we can take forward on Monday.
Okay, so you want to finish this now?
Maybe we can, yeah. So we can conclude today, and the second problem, let attendees go through this problem, and we'll be solving this on Monday. And you can give two more problems so that they can go through the problem statement.
Okay, okay. So I'll give another problem. I'll give another problem now.
Yeah, sure, please.
Okay, it will be a bit harder. So just two problems, I guess, will be okay. So this another one. Okay.
Yeah. One more, that's it. So one more may be hard.
Yes. Okay. Just a number theory problem here. Okay. From AdCoder. Uh, everyone make sure to register on AdCoder because it's a very good website and this is a good problem. So make sure to solve these two problems and have proofs for them, of course. So you will be explaining your answer. That's it. Okay. And we'll be solving we'll be passing through these problems next time. Okay. So do we finish now? Okay.
So guys, please go through this problem. I'll be sending you this in groups also. Maybe I can mail you also, and we'll take it forward. Maybe on Monday we'll be scheduling one more session of 1.5 hours or 2 hours, and we can discuss at the same time.
Yes. Yes.
Yeah. So uh, we'll be ending today's meeting, and thanks for joining. Thanks, Ahmed, for taking the session.
Okay. Thanks. Thanks, everyone. Okay. Bye.